Hi guys, so let's start with the retrieval augmented generation, right? RAG. So first of all, language models. So language models give us coherent and fluent answers. So by coherent, we means that they have a logical flow and those are like readable, right? They have a good readability. And by fluent, we mean that they have grammatical accuracy and they are linguistically accurate responses. So language models give us coherent and fluent responses. The challenge we are facing is the groundedness. So what is groundedness? So groundedness is basically whether your response is connected to specific context, reality, or factual information. So what we mean by our response is connected to this specific context, reality, or factual information. So for example, if you want to know uh, what is the maximum leave period in your company, right? So your LLM does not know about that, but that is the factual information. So maybe it is like the maximum leave period is 4 days or something like that, right? So it is in your company documents. So that is like how much your response is connected to that factual information, right? So that is what we mean by groundedness. So now let's see what's the difference between ungrounded prompt and a grounded prompt. So ungrounded prompt, like the LLM only uses the information it was trained on, right? It makes sense because the LLM only has access to the information it was trained on, so it will give response based on only that information. And this information, it is a large volume of uncontextualized text. So LLM does not has context of your company details, so it cannot answer questions related to your company, right? So that is why the data which on which LLM is trained on is a large form of uncontextualized text from the internet and other sources. So ungrounded prompt base their response only on that information. So it does not have that information or that context of your company. And although the responses are coherent and fluent, but they are not grounded to the factual data, right? And that is why they would give an inaccurate and invented information. So if you ask them like what is the maximum leave period, they might give an inaccurate information like it's generally 4 days or something like that, but that won't be an accurate information, right? They might even invent the information that yes, it is 2 days, right? So that is how they will respond. So it would be inaccurate and not relevant or invented information. Whether if we compare it to grounded prompts, so in grounded prompt we have a data source and we use that data resource to ground prompt, right? So we ground the prompt to that factual context. So like if we have a document of a company in which all the company guidelines are there, there might be some section which details about the leave period. So we will use that document as the data source to ground the prompt for to ground the prompt based on that document, right? So we can use prompt engineering here also, right? So we can just take that section of the document and paste that in our prompt and then ask our question that what is the leave period. But that does not make sense because it's just like you don't want to read that document, but like then you have to find the relevant sections from the document just to get the answer, get the response, right? So that's why we will use something called as retrieval RAG, retrieval augment generation, right? So we use the data sources to ground the prompt to that factual context. So what what we then submit to a language model is the prompt, the initial prompt, like what is the leave period, and the grounded data. So grounded data will be like listing all the information of the leave period, how much is the leave period, on what reasons you can get the leave, right? So all of that information will be in the grounded data and you will have prompt. So you will send both of this prompt, like your initial prompt and the grounded data, and you will submit that to language model. So this will result in a relevant and accurate response, and your LM will not make up stuff or invent information, and it won't be inaccurate because now it has that data source, it has that information. So so this data source will be a repository of relevant data, right? So now let's start to understand what is RAG. So for RAG, the each word retrieve augment generation. So first of all, it will retrieve the grounding data based on initial user entered prompt. So if a user has entered a prompt like what is the maximum leave period, right? Then it will retrieve the particular section in the document in our company guidelines and company document. It will find the particular paragraph or section, and it will retrieve that as a grounding data, right? If we have another question like what are the statutory holidays, right? So those kind of questions will lead to a different paragraph in the document, retrieval of a different paragraph in the document, then that will be retrieved as a grounding data. And after the grounding data has been retrieved, it will be augmented with our prompt. So the next step is that we will augment our prompt with that grounding data, and then we will send this both the prompt and the grounding data to the language model. And based on that, language model will give a grounded response, because right now it not only just has the prompt, it also has the grounding data, and the retriever basically gets the relevant grounding data from the initial prompt. We could also use prompt engineering in this case. So in case of prompt engineering, we will put our prompt, and then we have to retrieve the relevant portion of the document. But that is counterproductive, because you will be going to retrieve the document, then you can get the answer, right? So that is what this retrieve document generation does. It helps us to basically retrieve that relevant data and put that with our prompt. It augment our prompt with that grounding data, and then we send that grounding data and the prompt to the language model to generate a grounded response. So now we have we get a relevant response, relevant and accurate response because of this. So what kind of data connections? So we need to add the data, right? So from where we can add this data? So we can add this data from Azure Blob Storage. We can add this data from ADLS Gen 2 Microsoft OneLake, right? And we can also directly upload files and folders. So there are a lot of ways in which we can basically connect our data in AI Foundry project. Now let's understand what is how can we make our data searchable, right? So Azure AI Search, which is a service, right? It is basically a retriever. It functions as a retriever. So first of all, what we have to do, we bring our own data. So bring your own data, right? So this data can be present in blob storage, or we can directly upload files and folders, right? The next step is we index that data. So we will understand what we mean by indexing data. So we also index data in our databases, right? So we basically index data, and then once the index is created, we query the index. So who all does this? There is an indexer which does all this work, right? To index our data, and then when we query that index to get our data. So the retriever, first of all, we will bring our own data from one of the sources like blob storage or files and folders or other data sources. We will bring our data. So retriever will basically index our data, and then when we want to query, we will basically query the index, right? So it can be used with prompt flow. So we can use this Azure AI search with prompt flow also. So now let's understand what is vector index. So vector is basically when you have a document, right? So you want to know the meaning. So traditionally how search was performed, like it was based on keyword search. So if we search something, like if we search for leave, and there is anywhere like leave in the document, then it will search based on the keywords. But in vector index, it's different. So first of all, let's understand what's an embedding. So embedding is a vector of floating point numbers. So there will be a lot of you can say an array of floating point numbers like this, like 0 0.3 comma 0 0.4 dot dot dot, lots of floating point numbers, right? So embedding is just a vector of floating point numbers, right? And what it represents, so whatever the text tokens are, it represents the meaning of that text, text tokens, right? So that is what we mean by embedding. So we will create embedding for our different portions of the document, right? We will basically chunk our document in different places, right? So in different size, we will decide the chunk size, and then we will basically chunk our document into parts, and then for each part there will be an embedding generated, right? And that would be a fixed size depending on which embedding model you will use. So there are different embedding models which are being provided by different AI companies, right? So we will use that embedding model to basically get the embedding of our chunks of data. And then let's understand what is cosine similarity. So basically when you will plot these vectors on a graph, right? So this is a vector. So it is easily visualized on two-dimensional space. So when you plot these on the graph, so based on the cosine angle, right, between them, you can get the similarity. So the vectors which will have a similar meaning, like a boy and a man, so they have almost similar meaning. So they will be really close, but like a boy and a laptop will be very different, so they will not be very close. So based on the semantic meanings, the vectors are closer to each other, like based on this semantic similarity, we can basically query our document. So we will create a embedding vector for our query, whatever query we have, and there are embedding vectors of our document stored, right? So these embeddings of our documents are stored uh, in a vector store, right? So this is what we call index. So like when we index our data, so we are basically converting our data into embeddings, and then we are storing those embeddings, right? So whenever a query comes, we will create an embedding of that query, and then we'll try to match that query with all the embeddings, right? So that's how the similarity search works. So this is the basic kind of similarity. There are more advanced kind of similarity searches in which you don't have to even go through all the indexes, right? Go through all the index data. So that is how this cosine similarity works, right? So it's basically the similarity between the vectors. Then why are we calculating the similarity between vectors? Because these vectors are representing semantic meaning, the meaning of the word, right? It's not just a keyword search, right? So that is what we mean by a vector index. So this works even data is stored in text, image, or different language. So the main idea behind this is that we are converting our text into an embedding, that is this vector of floating point numbers, right? So we are converting our text into that. We can also do the same thing for image. This vector is representing the meaning. So if there is an image for a cat, then that vector, that embedding we have generated, that numbers will represent the meaning, right? So this can be this works even with the images, with the text, and even with different languages. It doesn't need to be just English. It can be any other language like French or Japanese or anything else, right? So so it works for all of them, right, based on the embedding models and those things. So to create embedding, we can use OpenAI embedding model, which we can found in Azure AI Foundry's model catalog. So we basically create embeddings using our embedding model, and then a search index is created by our Azure AI search, right? So we create a search index for that, and we create the search index using Azure AI search and embedding model. So we specify what embedding model we want, and Azure AI search creates the search index, right? And then this search index asset is stored in the Azure AI search. So we have to store this, all of these embeddings, and all of this is stored in a particular manner in a index in vector stores, right? So this is basically stored by, taken care of and managed by Azure AI search. So we have different kind of search. We have keyword search, right? We have vector search, and we also have a hybrid kind of search which combines both the keyword and the vector search. So that's all.